Captain Peter Cutsey, part 3 of the No Engine Bleed Takeoff and Landing series. We are in the holding pattern right now over Weibo in the Kabul area, and we're level at 14,000. Remember, this is a high altitude airport. So that's our position here. We will be executing the ILS to runway 29, 110.5. So we have done the pre-descent procedure and the approach procedure and respective checklists. We're in the hold at 14,000. The weather is IFR. The temperature is +3 at the field. So we have selected engine anti-ice on, as you can see here. And in our discussions before, we fully understand that we will have engine anti-icing even when we turn the engine bleeds off. Remember what we talked about in the second and first videos. We're not anticipating the requirement to use wing anti-ice, so we're fine for this approach. Now, let's go to the PowerPoint and have a look at what we have here. The certain carriers, I'm using one carrier here as an example, and I'm sure most carriers do the very close to the same thing. There are restrictions at that airport. Each carrier going into that airport has their engineering department compute an engine out for, let's say, when executing an ILS to runway 29. There are basically 3 approaches in Kabul to runway 29, an ILS, an RNAV approach, and a VOR approach. They have different minimums. They have different climb gradients required in the event of a go-around, in the event of losing an engine. And some carriers have actually got approval to do an engine out procedure. And this is just a sample of one of those engine out procedures here. And we'll actually have a look at that on the fixed page. So we'll actually put Kabul VOR on the fixed page with a 6.5 DME ring and also 247 radio, because we'll be flying inbound 067 in the event of go around and losing an engine. If the airport authorities are not allowing your company's approved engine out procedure for that particular approach, in this case, for the ILS to runway 29, via NOTAM, you know that you can't use it for whatever reason, you will have to follow the published missed approach procedure, right? Now, remember, the TOGA to LNAV will give guidance to the published missed approach procedure. If your company's approved engine out procedure for, let's say, the ILS is in effect, and you're going to be using it if you lose an engine, you will actually have to follow this procedure here. But remember, when you depress TOGA, TOGA will give you guidance to LNAV to the published. So pushing TOGA is important, but immediately pushing heading cell so that you can actually manually input a heading of 155 using 25 degrees angle of bank to follow and intercept the 247 radio, which is 067 inbound, and maintain go-around flaps until established on the 247 radio. That's to ensure that you have a minimum radius of turn. And then you follow the missed approach altitude and holding as per listed here. Now, this is the approved procedure that this particular carrier received from the airport authorities in Afghanistan. So not to be confused. So for any approach that you do to this airport in Afghanistan, you have to be thoroughly briefed, not to mention the fact that you have to be trained in all these procedures in the simulator. So we'll assume that today you've received that training, all your training was acceptable, and we'll assume today that the approved procedure that your company received for the engine out in the event that you had an engine out and you had to go around, we'll assume that that procedure is not allowed today. Therefore, we will follow the published missed approach procedure, which is here. So the missed approach is climb to flight level 180 via the Kabul 287 to Ralroy, then turn right, direct to Kabul and cross Kabul VOR, and proceed on the Kabul 195 to Lavri and hold. So that's what we will be doing today. And it's important that this briefing is given between the pilot flying and pilot monitoring for any approach going into Kabul. Now, we're going to be demonstrating the fact that we want to do an engine bleed off approach so that we have more thrust in order to make good the gradient. And it's also a safety factor also. Now, remember, there are certain gradients required depending on the approach. We are doing an approach, an ILS approach, and with a gradient that is required of 350 feet per nautical mile. So we'll say that our aircraft is capable of doing that. We know that from our engineering department. Therefore, our minimums, if you notice, are lower. If we didn't fall into the category of 350 feet per nautical mile, our minimums would be considerably higher. So it's important that you understand what we're talking about. The other thing you want to look at, because of the terrain going into this airport, there's the vertical profile and the minimum altitudes. We are going to be on a 3.5 degree glide slope. Here it is here, glide slope of 3.5 degrees. And you can expect with a speed of 160 knots, ground speed of close to, the glide slope, which should say the rate of descent will be close to 991 feet per minute. So a fairly high descent rate on the 3.5 degree glide slope. So the briefing to this airport is super important. Now, let's go to the actual no engine bleed landing, and we'll say we want the additional thrust. And especially if we lost an engine and we had to go around. Remember, today we're going to follow the published missed approach procedure for the reasons we mentioned at the beginning of this briefing. So, wing anti-ice off. Well, we're not anticipating any icing today in cloud, and the reports are such that there isn't. But we do have engine anti-ice on. The right pack switch, auto. And by the way, this is when below 10,000 feet. We're at 14,000. So let's have a look at the profile. We're looking here at Milo. Milo is 10,600. So after passing Milo, we're going down to Stitch. So at Stitch is when we're going to start to configure. So this is going to be a busy time. Pilot flying's got to focus on just flying the airplane, nothing else. And this has to be really well briefed, that the sequence of events. Now that's why it's important to follow the C on setting up and the reversed C, as we discussed in the previous videos, to know what you're going to do. You don't have time to be pulling a book out when you're on a glide path and you're flying in cloud and you're the pilot monitoring. So it's important that you get these procedures salted away and you review them first so that you can do them. But following the C setup and then later on a missed approach, you're going to have to reinstate. And then because this is a high altitude airport, we've got restrictions. Remember, the APU has limitations. You can use the APU below 10,000 for both air conditioning and for electrics, below 10,000 feet. But right now we're sitting at 14,000. We've got the APU running. We started it already. So we can only use the APU here for either electrics only, or we can use it for pressurization, but we can't use it for electrics. All right, so that's important. It's important, especially if you have to go around, because you're going up to flight level 180. And remember that you're restricted to the APU providing pressurization to the aircraft, which you're going to be doing with the bleeds off landing. You're going to be, you're restricted to 17,000 feet as far as the APU providing pressurization. So you've got to reinstate the engine bleeds prior to 17,000 or flight level 170, because you're going up to flight level 180. So this particular maneuver has to be really well briefed and understood. All right, so we talked about wing anti-ice off, right? Right pack, now we're going into the C. Right pack auto, isolation valve, closed. Left pack auto, engine number 1 bleed air switch off, APU bleed air switch on, engine number 2 bleed air switch off. This will be done by the pilot monitoring. While the pilot flying is flying. And we can't start it today until stitch, because it has to be done below 10,000. There's the C. All right, we know that. All right, so that's going to be done. And then let's say we're going to go around, and we'll do that today. We'll go around. So we'll fly the airplane. Remember the go around procedure. The pilot flying says go around, depressing the toga switch, ensuring both pilots ensuring the FMAs indicate toga and go around respectively as thrust is increasing to go around thrust and the aircraft is pitching up towards 15 degrees. All of that is important before you call flaps 15. Flaps 15, positive rate, and that's on the barometric altimeter. Gear up. And then carry out the missed approach procedure. So remember that if an engine failure occurs, do not position the engine bleed air switches on until reaching 1,500 feet. We're not going to have an engine failure today, but this is very important that you know that. So engine number 2 bleed air switch. Now remember, we are going on the reverse C. Engine number 2 bleed air switch on. APU bleed air switch off. Note, when the cabin rate of climb indicator stabilizes, engine number 1 bleed air switch on. Isolation valve switch auto. All right, so what are you going to do all this? Well, you want to make sure that the flaps up, lights out, then you can reinstate. Now you may, providing you're happy with your rate of climb and you're happy with the restrictions and you're happy with your vertical situation display, don't rush into doing this procedure until you fly the airplane first. But you've got to get this procedure done, ideally before you leave 10,000, but you're good to 17,000 as far as the APU is concerned, giving you the pressurization that you need. Remember, that's important. All right. So there is the reverse C. So be well briefed on this maneuver before you execute it. So we'll get into the airplane now. We'll go ahead and do this. And remember, we can't set up until stitch, which is here, which is 10,200 feet. Now, we're not going to be doing this step down approach. We're going to be doing a glide path approach on a glide path of 3.5, as we discussed here. All right. So basically, when you go through 10,000, one pilot will alert the other pilot, go ahead with the engine bleed procedure. Okay.